Courses in the cement industry. Present to you. In this course we will explain everything about belt bucket elevators, common components and troubleshooting. Part 2. Bucket elevator head consists of 1. Shaft casing, 2. Head casing, 3. Drive pulley, 4. Protective cover. Bucket elevator head. The bucket elevator head is dispatched pre-assembled. First, the head casing is mounted to the upper shaft casings. The drive pulley is to be aligned so as to be parallel, horizontal, and vertical to the take-up pulley. After the traction carrier has been mounted, the protective cover is fastened. Drive bracket consists of 1. Drive bracket, 2. Head casing, 3. Adjusting screws, 4. Protective hood. Drive bracket. The drive bracket is screwed to one side of the bucket elevator head. The drive bracket is aligned with the adjusting screws. The drive shaft of the bucket elevator and the output shaft of the gear unit must be aligned properly and truly horizontal to the drive bracket. After the test run, the drive bracket is to be welded to the head casing. The permissible tolerances and the dimensions for adjustment of the individual sub-assemblies are indicated in the operating instructions included in the annex. The tolerances indicated are to be observed, as the operational reliability of the machine depends on this. Bucket elevator belt assembly consists of 1. Inspection hatch, 2. Unwinding trestle, 3. Take-up device, 4. Tie strap. Bucket elevator belt assembly. The belt is dispatched rolled up on a square timber. In order to avoid damage to the belt, we recommend using an unwinding trestle for the assembly. For mounting the belt, the free belt end is screwed to a tie strap. The belt is inserted by a mechanical or an electric winch. Belt clamping connection. The belt clamping connection is an essential component of the bucket elevator belt. Both belt ends must be connected carefully to each other. An incorrectly mounted belt clamping connection cannot absorb the existing tractive forces. In this case, the connection may loosen, and the belt may fall down. As the tractive forces are only absorbed by the steel wires of the belt, the ends of the steel belts must be connected to each other. For this, the individual strands of the steel wires are pressed in a U-shaped part and cast. Close the belt clamping connection. Consists of 1. Clamping jaw, 2. Center, 3. Belt. Close the belt clamping connection. The belt clamping connection is closed in the bucket elevator boot. For this, hexagon head screws M24, strength 8.8, galvanized, are used. Starting in the center of the belt clamping connection, first the long screws are inserted alternately, on both sides, and the nuts are screwed on. Then, the short screws are mounted in the same way. Pay attention to the correct arrangement of the conical spring washers. The leads of the screws must not be damaged. Tighten the belt clamping connection. The screw and bolt connections are tightened evenly by an adequate torque wrench with 500 Nm, starting in the center of the belt clamping connection. This process is to be repeated until all screw and bolt connections have been tightened with the required tightening torque. After that, the screw and bolt connections are to be fixed by lock nuts. Check the screws of the belt clamping connection for their tightening torque at the intervals fixed. For this purpose, remove the lock nuts. If one or several screws are defective, all screws of the belt clamping connection must be replaced by new ones. Cast the belt clamping connection. Consists of 1. Steel wire belt. 2. Clamping jaws. 3. Clamping device. 4. U-shaped part. 5. Strands. 6. Casting metal. Cast the belt clamping connection. It is quite easy to carry out the work when the belt clamping connection is placed centrally on the drive pulley. The individual steel wires are inserted into the U-shaped part. Then each U-shaped part is pressed onto the clamping jaws by 2 clamping devices. It must be ensured during installation that the U-shaped parts lie on the clamping jaws over their whole length. The U-shaped part has to be sealed by sealing compound on all sides. The casting metal, white metal, is to be heated up in a metal receptacle. The quantity must be sufficient to fill the complete U-shaped part. Use a thick-walled tank so as to heat the casting metal to 358 degrees C or more and to store the heat. Heat up the casting metal right next to the belt clamping connection to avoid a drop in temperature between the heating up and subsequent casting of the metal. If there are shrink holes, the casting metal is to be liquefied by spot heating once again. After casting, the surface must be free of shrink holes. Any projecting wires can be ground off after the casting metal has hardened completely. Bucket with segment fastening. The buckets and the rubber plates are fastened to the belt with screws and segments. For this, the bucket and the rubber plate are held to the belt. Then the screws are put through the segments, the belt, the rubber plate and the bucket from the belt's contact side. The screws are fastened with special nuts. To improve the power transmission of the steel wires, the belt's contact side is provided with recesses for the segments. Counterweight. The belt is heavier in the area of the belt clamping connection than on the opposite side. In order to equalize the difference, counterweights are welded into the buckets opposite the belt clamping connection. The number of counterweights supplied is such as to ensure that the belt is in balance. How to adjust the discharge plate. An adjustable discharge plate is located in the bucket elevator head. The position of this discharge plate affects the fallback of spillage into the bucket elevator boot. In order to keep the fallback of material low, the spacing between discharge plate and bucket edges must be as small as possible. The minimum spacing must be 10 to 20 mm, according the bucket elevator size. This spacing is to be checked and adjusted during commissioning, if required. Troubleshooting. See this table. What to do if. Problem 1. The belt bucket elevator does not start, or stops during operation. Possible cause 1. The discharge system is not in operation. Solution. Switch on the discharge system. Eliminate functional disorders, if any. Possible cause 2. A belt misalignment has resulted in a disconnection of the bucket elevator, after the limiting value has been reached. Solution. Find out the cause of the belt misalignment, and eliminate it. Then correct the running of the belt. Possible cause 3. The bucket elevator boot is overfilled, and the fill level indicator has disconnected the bucket elevator. See, the bucket elevator boot is overfilled. Solution. Find out the cause and eliminate it. Then clean the bucket elevator boot. Possible cause 4. The take-up pulley does not rotate correctly, and the speed monitor has disconnected the bucket elevator. See malfunction of speed monitor. Solution. Find out the cause and eliminate it. Possible cause 5. The fluid coupling is overloaded, and the thermal switching device has disconnected the bucket elevator. See malfunction of fluid coupling. Solution. Find out the cause of the overload and eliminate it. Problem 2. The indicated conveying capacity is not reached. Possible cause 1. The buckets are not filled sufficiently. Solution. Check and adjust the material guide, so as to ensure a central feed of the material conveyed into the buckets. The conveying capacity of the feeding system is to be adapted to the conveying capacity of the bucket elevator. Possible cause 2. The discharge plate is not aligned in an optimum way, and the material conveyed falls back into the bucket elevator boot. Solution. Push the discharge plate closer to the bucket track. Keep the minimum spacing of 10 mm. Possible cause 3. The material conveyed adheres to the buckets and chutes. The features of the material conveyed have changed. Solution. Clean the buckets and chutes. If required, adapt the buckets and chutes to the changed features of the material conveyed. Problem 3. The bucket elevator boot is overfilled. Possible cause 1. Material caking affects the functioning of the fill level indicator. Solution. Check the functioning of the fill level indicator. Remove the material caking. Possible cause 2. The bucket elevator outlet is blocked. Solution. Find out the cause and eliminate it. Possible cause 3. The discharge system is not in operation. Solution. Switch on the discharge system. Eliminate functional disorders, if any. Possible cause 4. The feeding system is overfilled. Therefore, a dosed feeding is not ensured. Solution. The conveying capacity of the feeding system is to be adapted to the conveying capacity of the bucket elevator. Possible cause 5. The discharge plate is not aligned in an optimum way, and the material conveyed falls back into the bucket elevator boot. Solution. Push the discharge plate closer to the bucket track. Keep the minimum spacing of 10 mm. In case of wear and tear, replace the discharge plate. Problem 4. Malfunction of speed monitor. Possible cause 1. The proximity switch or the control device is defective. Solution. Check the operating distance of the proximity switch and the setting of the control device. Adjust both, if required. Possible cause 2. The take-up station does not function. Solution. Check the mobility and the take-up distance. Possible cause 3. The take-up pulley is lifted, due to strong material caking, in the bucket elevator boot. Solution. Clean the bucket elevator boot. Possible cause 4. There are foreign particles in the area of the bucket track or the belt. Solution. Check the bucket elevator and remove foreign particles. Check the running of the belt. Problem 5. Belt misalignment in the bucket elevator boot. Possible cause 1. The take-up pulley is worn out, crowning. Solution. Replace the take-up pulley. Possible cause 2. The take-up pulley is lifted due to strong material caking in the bucket elevator boot. Solution. Clean the bucket elevator boot. Possible cause 3. The material is fed into the buckets. Solution. Check the material feed. The material must be fed in the middle of the buckets to one side. Possible cause 4. The end of the take-up distance has been reached. Solution. Move the lever arm of the take-up station into a horizontal position. Shorten the belt, if required. Possible cause 5. Inclined position of the counterweight. Solution. Adjust the take-up station and, for recommissioning, readjust the running of the belt at maintenance speed. Problem 6. Belt misalignment in the bucket elevator head. Possible cause 1. The drive pulley or the segmented laggings are worn out, crowning. Solution. Replace the drive pulley or the segmented laggings. Possible cause 2. The drive pulley shows strong material caking. Solution. Clean the drive pulley. Possible cause 3. The drive pulley has not been aligned horizontally. Solution. Align the drive pulley in order to correct the running of the belt. Problem 7. Malfunction of fluid coupling. Possible cause 1. The fluid coupling is overloaded, and the hydraulic oil has reached the maximum permissible temperature. The safety switch has switched off the bucket elevator. Solution. Find out the cause of the overload and eliminate it. Replace the thermal circuit element, see the manufacturer's operating instructions. Possible cause 2. The bucket elevator is overfilled. Solution. Check and adjust the material guide, so as to ensure a central feed of the material conveyed into the buckets. Before restarting the bucket elevator, empty the bucket elevator boot. Possible cause 3. The bucket elevator boot shows strong material caking. Solution. Clean the bucket elevator boot. Possible cause 4. There are foreign particles in the area of the bucket track, or the belt. Solution. Check the bucket elevator, and remove foreign particles. Check the running of the belt. Maintenance. How to correct the running of the belt. See in this figure. 1. Take-up pulley. 2. Parallel take-up device. 3. Take-up spindle. 4. Nut. The conveyor belt must run centrally, on the drive pulley and the take-up pulley. During one rotation, the belt may move up to 30 mm, to the right or to the left. The tolerance depends on the bucket elevator size. If the belt tracks off by more than 30 mm, the take-up pulley must be readjusted. The position of the take-up pulley is adjusted with the lateral take-up spindles. The take-up pulley is to be located in the center, or in the upper third of the take-up distance. The running of the belt can only be corrected if the drive pulley is exactly aligned. Maintenance. How to align the take-up pulley. 1. The belt tracks off on the take-up pulley, in the direction of the arrow. 2. Adjust the left take-up spindle, upwards with the nuts. 3. If the end of the adjusting path, for the left take-up spindle has been reached, adjust the right take-up spindle downwards. 4. Once the take-up pulley has been aligned correctly, the nuts on the take-up spindles must be tightened. Notes. Adjust the take-up spindle step by step. Then observe the running of the belt for several rotations, as the effect of the correction only appears after some time. Preventive maintenance. For elevator. 1. Turn on the elevator by auxiliary drive. 2. Check for abnormal noises, temperature and vibration. 3. Check the buckets for deformation, wear, cracks and fastening. 4. Check the belt for wear. 5. Check all the belt joints. 6. Check the drive pulley, check the rubber coating. 7. Check the driven pulley. 8. Check the alignment of the belt. 9. Check the tension of the belt. 10. Measure the hardness of the belt, must be between 60 and 90 SHORE. 11. Check and clean the electromagnetic. Preventive maintenance. For drive. 1. Disconnect the power supply. 2. Check the bearings and housings of the drive pulley, fastening, lubrication, clearance. 3. Check the gearbox, oil level, wear, leakage, fastening, clearance. 4. Check the inlet and outlet couplings, alignment, mechanical integrity, clearance between faces. 5. Check the backstop. 6. Check the counterweight. 7. Check the bearings and housings of the driven pulley, fastening, lubrication, clearance. 8. Check and clean the electromagnetic. 9. Check the deflecting plate in the elevator discharge. 10. Check the drift switch. 11. Check the speed switch. 12. When there is drive unity, it's need to check if exist or not oil inside the motor, damage in the sealing. 13. Reassemble the equipment. 14. Testify the equipment. Collect all the stuffs, tools and spare parts used during the job request execution. Thank you for watching, and I hope these courses are helpful to everyone. Subscribing to this channel Cement Industry Courses would be appreciated. Thank you.